Okay, look at this circuit. So this network is being driven by, a sinusoidal voltage source whose value is what? 2 sine 1000 t. So let this be capital Vn. Okay, phasor input voltage is what? Capital Vn. And this network contains what? 3 identical resistors and also 3 identical capacitors. R value is what? 1 kilo ohm, C is what? 1 microfarad. You should find I of t at steady state in what units? In the units of milliamps. Again, this I of t in the phasor domain will become what? Capital I. I mean, it's all about finding the equivalent impedance of this network. Once you find the equivalent impedance of this network, you know capital I, it is going to be the phasor input voltage divided by the equivalent impedance. Phasor input voltage divided by equivalent impedance. So it's a problem on finding equivalent impedance. Okay. See, let us do it. What is the impedance of each capacitor? Before that, what is the frequency of operation? Frequency of operation, is it not 1000 radians per second? And at this operating frequency, what is the impedance of any capacitor going to be? Any capacitor will have an impedance of 1 by j omega c, which is 1 by j times omega is what? 1000. C is what? 1 microfarad, which is 10 power minus 6. So I think it is minus j 1000 ohms. That is the value of the impedance of every capacitor. So there are 3 capacitors. If you look at the 3 capacitors, are they not connected in the shape of star? Yes or no? The 3 capacitors are connected in the shape of what? A star network. Okay. So it is like this. This is Z, this is Z, this is also Z. Any star connection of 3 impedances can be transformed into what? An equivalent delta network of another 3 impedances. Okay. Right now we are not focusing on resistors, we are only focusing on the 3 capacitors which are connected like this. Okay. So what I am going to do, I will replace the star connection of the 3 impedances with a delta network of another 3 impedances. What is the value of this going to be? Z into Z plus Z into Z plus Z into Z, which is what? 3Z square divided by Z. 3Z square divided by Z. Is it not going to be 3Z? Yes. So this is going to be 3Z. This is also going to be 3Z. This is also going to be 3Z. Remember the value of Z is what? ZC, which is minus j 1000. So 3Z will be what? Minus j 3000 ohms. Minus j 3000 ohms. Okay. I think we should go to the next slide. So the network, it is what? Like this. So here we have the input source Vi. This is what? The input current I. I think this is R, this is also R, this is also R. Now we got the 3 new impedances, right? Like this. So what is the value of each green color impedance? Minus j 3000. Value of resistance is what? 1 kilo ohm. So this is what? 1000 ohms, and this is what? Minus j 3000 ohms. Okay. That's all. Now let's call this as what? Z1. This as what? I mean, this is also Z1, right? This is also Z1. Okay. Now if you look at this Z1 and this Z1, both are in series. So Z1 in series with Z1 is what? 2Z1, And this 2Z1, is it not in parallel with this Z1? 2Z1 parallel Z1, 2Z1 parallel Z1 would be 2Z1 by 3, okay? That's all. The equivalent impedance is what? 2Z1 by 3. I hope this is correct, okay? So these two will become what? Z1. These two also will become what? Z1. These two also will become what? Z1. Then this Z1 and this Z1 both are in series. So Z1 in series with Z1 is what? 2Z1. And this 2Z1, it is in parallel with this Z1. 2Z1 parallel Z1 is what? 2Z1 by 3. So we just have to find Z1. So Z1 is what? Parallel combination of 1000 parallel minus J 3000. So Z1 is going to be 1000 times minus J 3000 upon 1000 plus minus J 3000. I'll directly write it as 1000 minus J 3000. Okay. I think 1000 is common to both numerator and denominator. So will it not be 3000 at an angle minus 90 degrees divided by 1 minus J3, correct, right? 1 minus J3, because 1000 will come out and it will get cancelled. What will be left? 1 minus J3. What is 1 minus J3 in polar form? 1 minus J3, first of all, 1 minus J3, it lies in what? Fourth quadrant. The angle would be negative. 1 minus J3 magnitude would be what? Square root of 1 square plus 3 square, which is root 10. So 3000 divided by square root 10, angle minus 90 degrees divided by the angle of the denominator. I think it would be negative and equal to what? Minus tan inverse 3. Minus tan inverse 3. What is tan inverse 3? Someone please tell me the value of tan inverse 3. Tan inverse 3, 71.56. Okay. So is it not minus 71.56 degrees? Because this 1 minus J3, it lies in what? Fourth quadrant. Any phasor that lies in fourth quadrant, the angle would lie between 0 and minus 90 degrees. That's all. Angle of numerator minus angle of denominator, I think it will be, okay, before that 3000 by root 10. 3000 by root 10. 3000 by root 10 will be 300 root 10. 300 root 10 at an angle minus 90 degrees plus 71.56 degrees. I think it will be minus 18.44 degrees. This should be correct. Okay. Yes, minus 18.44 degrees. What are the units? Ohms, right? We are finding impedance. Units will be ohms. I think now we can find the value of Z equivalent. So Z equivalent is what? 2 by 3 into 300 root 10 at an angle minus 18.44 degrees ohms. Again, 300 by 3 is what? 100. 100 times 2 is what? 200. I am getting this 200 root 10 at an angle minus 18.44 degrees ohms. That is what? Z equivalent. What is the input source? Input source value is what? 2 sine 1000 t. Okay. Two sine 1000 t divided by the equivalent impedance, which is 200 root 10 200 root 10 at an angle minus 18.44 degrees. This is volts, this is what? Ohms. See, strictly speaking, you should not write this equation because the numerator is what? In terms of time. and the denominator is what? A complex number which is in the phasor domain. But still we can do it. I mean in that way we don't have to convert the the input voltage into phasor again, convert it back to what? Time domain. Directly we can do it. I think it is asked in milliamps, right? Because it is asked in milliamps, you can just multiply it with 1000 milliamps. Okay, so volts by ohms is going to be amperes. 1 ampere is what? 1000 milliamps. Okay, I think 200 goes into 1000, right? 200 goes into 1000 as what? 50. Is that correct? 200, no, 5, sorry. 200 goes into 1000 as what? 5. 5 into 2 is what? 10. 10 by root 10 is again root 10. So root 10 sine 1000t plus, because the angle in the denominator is what? Minus 18.44. 0 degrees minus of this is what? Plus 18.44 degrees. Okay. This is the current in milliamps. Is it correct? Did you also get the same thing? Root 10 sine 1000t plus 18.44 degrees. So tell me which one is leading, current or voltage? Which one is leading? The applied voltage is what? Sine 1000t, whereas the current drawn from the applied voltage source is what? Sine 1000t plus 18.44 degrees. So clearly I leads V. It should be, because the network contains what? Only capacitors. If you look at the original network, where is it? If you look at the original network, it contains what? Only capacitors. So the overall nature of the network is definitely capacitive. Definitely capacitive. That means what? Current should lead voltage. That's why the input current will lead the input voltage. Okay. So if the network contains only capacitors, it will have capacitive nature. There is no possibility of having an inductive nature. Okay. Okay, this is an infinite ladder network which contains what? Inductors and also capacitors. Which contains what? Inductors and capacitors. The equivalent impedance is what you should try to find. Okay. Because there are infinite number of sections, first of all you should identify which section is getting repeated. Okay. So let us identify one unit section. I'll just highlight one unit section. Please look at this section, J9 and then J5 in series with minus J1. Is it not this thing that is getting repeated? Yes or no? It is what? This section that will get repeated infinite number of times between these 2 points, and you should find what? Equivalent impedance. Okay. Now if you take out one section from infinite number of sections, still you will be left with infinite sections. Okay. That means if you look at the yellow color part of the network, even the yellow color part of the network, does it not contain infinite number of sections? So from the original network, it is like removing one section. So if you remove one section from infinite sections, still you will be left with infinite sections. So for the original network, if the equivalent impedance is what? Z equivalent. Even for this yellow color network, which also contains what? Infinite number of sections, the equivalent impedance is going to be Z equivalent, which means we can replace the yellow color network which has infinite sections with one single impedance whose value is what? Z equivalent. So the network, so the original network can be redrawn like this. Look at this. So first we have the first section which contains what? An inductor J9. You see, if you look at this branch, J5 in series with minus J. J5 in series with minus J. What is the net impedance of this branch? J5 minus J. Just add the impedances. J5 minus J. Is it not J4? Yes. So what I will do, it's like having a single inductor whose impedance is what? J4 ohms. I'm just combining these two elements, okay? J5 in series with minus J is what? Just J4. And then this entire yellow color network is getting replaced with a single inductance, sorry, not inductance, single, in fact it is inductance, okay? I'll explain why. Single impedance whose impedance is what? Z equivalent, okay? And even now the equivalent impedance is still going to be what? Z equivalent, okay? You see, now this thing, what is the impedance of this thing? Z equivalent, let me write it properly. Z equivalent times J4 upon Z equivalent plus J4. That is the equivalent impedance of this part of the network. And this thing, is it not in series with J9? So Z equivalent between these 2 points will be equal to what? J9 plus this impedance, which is J9 plus Z equivalent into J4 upon Z equivalent plus J4. That's all. What is the only unknown in this equation? Z equivalent. In fact, when you take LCM and so on, you'll get a quadratic equation for Z equivalent. That means what? There will be 2 roots, or you'll get 2 different values for Z equivalent, okay? I'll just copy this and solve the equation in the next slide, okay? I hope it is clear up to this point. So this is the equation we have. So let us take LCM and so on. Z equivalent square plus J4 Z equivalent is equal to J9 Z equivalent, J9 into J4. J square is what? Minus 1. So J9 into J4, it must be minus 36, plus again J4 Z equivalent. Correct? I hope this is correct. I think this J4 Z equivalent on the left side and this J4 Z equivalent on the right side both will get cancelled, so that the final quadratic equation is going to be Z equivalent square minus J9 Z equivalent plus 36 equal to what? 0. So now it is in the proper quadratic equation format, okay? Ax square plus bx plus c. So here A is what? 1, B is what? Minus J9, C is what? 36. So what are the 2 roots of this equation? Minus b plus or minus square root of b square minus 4 AC. Someone please tell me the 2 roots of this equation. So what are the 2 roots of this quadratic equation? Please tell me. Yes, anybody? Please tell me the 2 roots. Minus 3j and 12j. Others please confirm. Very good, thank you. So Z equivalent is what? Minus J3 ohms or plus J12 ohms. So now the question is, which is the invalid root and which is the valid root? So tell me which is the invalid root, minus J3 ohms or plus J12? Which is the invalid root? Which is the invalid root? Minus J3 or plus J12? Minus J3, very good. See, minus J3, see both minus J3 and plus J12, real part is what? 0. That means it's a purely reactive impedance. It's a purely reactive impedance. Or the network is what? Purely reactive. Purely reactive, it means what? It will be either purely capacitive or purely inductive. Purely capacitive, capacitance has what? A negative reactance. So minus J3, it implies what? The network is capacitance, and the network behaves like what? A pure capacitance. And plus J12, it is what? Inductive. So if you go back to the original network, see this is what inductor, this is what inductor. But if you look at this branch, this branch, this branch, every branch contains what? Inductor in series with capacitor. But you know, inductor in series with capacitor can be clubbed into what? An inductor, because the net impedance of this branch will have a positive reactance. J5 minus J is what? J4. J4 is what? Positive reactance. Positive reactance, it means what? Inductor. Yes, so this can be replaced with an inductor. So this is inductor, this is also inductor. So everything is what? Inductor. The overall nature is also going to be inductive. In fact, it will behave like what? A single inductor. It will behave like a single inductor. That's why the the impedance is going to have a positive reactance. But for the first root, the reactance is what? Negative. So this is incorrect, this is correct. Okay. So what is the final value of Z equivalent? It is plus J12 ohms. It is what? Plus J12 ohms. Okay.